Okay, so let's have a look at what happens at the anode during the electrolysis of aqueous solutions. And what you can see here is the anode is where the anions are attracted to. So remember, anions are negative ions. Then they've got extra electrons, that's why they're negative. They tend to be non-metal ions, and we are going to have an oxidation reaction, therefore they're going to lose electrons when they get there. Okay, they're going to lose that negative charge. Again, there's a challenge here, because if we think about our example we've been looking at, and our example was using sodium chloride in an aqueous environment, then what we're going to have here is we'll have the chloride ion as an anion from the salt, and because it's aqueous, we will have the hydroxide ion. So which of these two is going to react first when it gets to the anode? To help us understand this, here's a little table, and I've listed all the halogens. They all have a single negative charge, and you notice each one of these contains one part. So we've got chlorine or fluorine or bromine or iodine inside there, so we've got one. Here the hydroxide is an O and a H, so this has two parts to the ion. And this one here is sulfur, S, and oxygen, but oxygen there's 4 parts. So here in total there are 5. So if we just count the number of parts that each ion is made up from, we can see that as you work your way up this list, then the ions become simpler. And the way for us to remember this is the simpler the ion is, the less parts it has, the easier it is to oxidize. So in my example here, where I've got chloride ions or hydroxide ions, if I come to that one now, which of these two is going to react first? If I use this to help me, I know that this has got 1 part, this has got 2 parts, the simplest goes first, so it's going to be the chloride ion. So the reaction I would get is Cl-, it's undergoing oxidation, so it's losing this electron. There's the electron released, being lost. Chlorine is diatomic, therefore I need 2 chloride ions, and I will release 2 electrons. And that reaction is oxidation, because it is losing the electrons. So this will react, the chloride ion will react first. If we have a look at another one here, a little bit more complicated. So would it be a sulfate ion, SO42-, or the hydroxide ion? Again, if I come back up to my table, sulfate ions contain 5 parts, so that's quite a complex ion. Here we've got hydroxide ion, which contains 2 parts. So it's going to be the simplest. So it's going to be the hydroxide ion that reacts first. This is a complicated equation for this one, and you need to remember this one. I'm going to show you a quick way to work this out. I'm going to write another one of these next to it, okay, just backwards so I can see what's going on. When these come together, they've got to create molecules with no charge. So these two come together by taking the H here, and this forms H2O. So that forms a H2O, which I know does not have a charge, therefore I'm getting rid of charges, that's okay. Here I've got OH-, another hydroxide molecule. That the O and the O can come together, and 2 oxygens come together makes oxygen. So O2 covalent, no charge. But I've got a charge left over, so I need another hydroxide ion to come along, and this will join with this to form, different colour pen, to form another water molecule which is covalent and doesn't have a charge. Therefore, if I now count this up, I can see that I've got 1, 2, 3, 4 hydroxide ions, and they are making 1, 2 lots of water, 1 lot of oxygen, and then I'm going to get 1, 2, 3, 4 electrons being released in the oxidation reaction. So this equation here is the half equation showing how the hydroxide ion undergoes oxidation. And you need to remember that equation, it's going to be really important, or remember how to do this. What would I see at the electrode? I get water forming, but I wouldn't see that. But what I would see is bubbles of oxygen gas forming as that is produced and this reaction proceeds.